Good day, everyone. Today I will be talking about one of the most well-known curves in mathematics, the parabola. It is a unique and beautiful shape that we can find not only in math problems, but also in real world, from satellite dishes to path of thrones objects. A parabola is a special type of curve formed by all the points that are the same distance from a fixed point called the focus and a fixed line called the directrix. This property gives the parabola its symmetrical U-shaped form. Focus. The focus is a fixed point inside the parabola. Every point on the parabola is equidistant from the focus and the directrix. The focus helps determine the shape and sharpness of the curve. The closer it is to the vertex, the narrower the parabola. Axis of symmetry. The axis of symmetry is a vertical line that passes through the vertex and divides the parabola into two mirror image halves. Every point on one side of this axis has a matching point on the other side. Directrix. Directrix is a fixed line below for upward opening or above for downward opening of the parabola. It works with the focus to define the set of points that make up the parabola. For any point on the parabola, the distance to the focus equals the distance to the directrix. Vertex. The vertex is the turning point of the parabola, the point where it changes direction. It can be the lowest point if the parabola opens upward, or the highest point if it opens downward. It's located halfway between the focus and the directrix. And lastly, the latus rectum. The latus rectum is a line segment perpendicular to the axis of symmetry that passes through the focus. Its length helps describe the width of the parabola at the level of the focus. Now, let's talk about the formulas for the different types of parabolas depending on their orientation or directions of opening. First, parabola opening upward or downward. Standard form. Opening parenthesis x minus h closing parenthesis to the power of 2 equals 4a opening parenthesis y minus k closing parenthesis. So the vertex is h and k, axis of symmetry is x equals h, focus is hk plus a which opens upward and hk minus a to opens downward. Directrix is y equals k minus a to upward and y equals k plus a downward. So, the second parabola opening is right or left, standard form. Opening parenthesis equals y minus k closing to the power of 2 equals 4a opening x minus h closing. Vertex is hk, axis of symmetry is y equals k, focus is h plus ak, which opens right, and h minus ak, which opens left. Directrix is x equals h minus a, which is right, and x equals h plus a equals left. Now, let's continue to the example. Let's find the equation of the parabola given focus at 0 and 1 and the directrix y equals 2. We know that a parabola is the set of all points that are equidistant from the focus and directrix. To find its equation, we'll use the general formula, which is y equals opening parenthesis x minus a closing to the power of 2 plus b squared minus c squared over 2 close opening parenthesis b minus c closing, where a and b is the focus and y is equals to c is the directrix. Now, let's substitute the given values. The focus is 0, 1, so a is equal to 0 and b is equal to 1. The directrix is y equals 2, so it's c equals 2. Now, substitute this value into the formula. Now we have y equals opening x minus 0 closing to the power of 2 plus 1 squared minus 2 squared over 2 or closing opening parenthesis 1 minus 2 closing. Now let's simplify them step by step. y equals x squared plus 1 minus 4 over 2 opening minus 1 closing. Now y is equal to x squared minus 3 over negative 2. Y is equal to negative x squared minus 3 over 2. Or we can also write it as y equals negative 1 over 2x squared plus 3 over 2. This tells us that the parabola opens downward because the coefficient of x squared is negative. Now let's graph it. The vertex lies halfway between the focus and directrix. Since the focus is at 1 and the directrix is at 2, the vertex is at y is equal to 1.5 or 0 and 1.5. The axis of symmetry is the y-axis because the focus and vertex are centered along x or equal to 0. Finally, we plot the focus at 0 and 1, draw the directrix line at y equals 2, and sketch the parabola opening downward through the vertex. In conclusion, a parabola is a special curve formed by all points that are the same distance from a focus and a directrix. By understanding its key parts, the vertex, axis of symmetry, focus, and directrix, we can easily write its equation and graph its shape. Parabolas are not only important in mathematics but also in real life, appearing in things like satellite dishes, headlights, and projectile motions. Learning how to find and graph a parabola helps us see how algebra and geometry work together to describe motion and design in the real world. That is all. Thank you.